Hi everybody, Leanne here. I'm going to talk about problems 5 through 11 for section 4.4. So that's chapter 4 on multiplication, section 4. This section is all about the distributive property. So let's get started. In number 5, here's our problem. There are 6 cars traveling together. Each car has 2 people in the front and 3 people in the back. And we have to use that situation to explain how to use the, or illustrate the distributive property. All right, so let's get down to it. So we know there are 12 people total in the front seats of the cars, and there are 18 people total in the back seats of the cars. So in other words, there are 6 times 2 plus 6 times 3 people. So there are 12 plus 18 or 30 people. You can think of it as 5 people per car. So you could think of it as writing that expression as 6 groups of quantity 2 plus 3, or 6 times 5, of course, then, which is 30 people. So this illustrates the distributive property because we're showing that 6 groups of 2 plus 3 is the same as 6 groups of 2 plus 6 groups of 3. All right, let's go to number 6. This time we have to draw arrays to help explain why the equations shown are true, and all of these are illustrating the distributive property. So in number 6, we're looking at the quantity 5 plus 1 times 7, and so we're showing in this drawing here that this is the same as 5 groups of 7 plus 1 group of 7. So I like to think of, when I read this with my students, I say groups of, so I'm always leaning on our definition of multiplication. So I would read that with them as 7 groups of 5 plus 1. So we have 7 groups of 5 plus 1. Here, this section, we have 7 groups of 5. And in this section here, we have 7 groups of 1. Or we could look at it as 1 times 7, 5 times 7. All right, in this one, we have 6 groups of the quantity 5 plus 2. And yes, I'm going to read it that way, 6 groups of 5 plus 2. And so when we draw an array, we can see that that's the same as 6 groups of 5 plus 6 groups of 2. All right, and this last one's a little trickier, so make sure that in your array you're showing it in a sense to show what part of it gets taken away, because with subtraction it's a little bit trickier. So we have 6 groups of, notice how when I read that I switch it around in my head, commutative property. So 6 groups of 10 minus 1. So 6 groups of 10 minus 1, that means I have 6 groups of 10, which is this entire rectangle. And then I'm taking away 6 groups of 1, or 1 group of 6. And so I have to show that the entire rectangle is 10 times 6, and that this section is the portion that I'm taking away. All right, number 7. You had to explain how to use the distributive property to make 31 times 25 easy to calculate mentally. And I love these mental procedures. We're also going to draw a rough picture of an array that would illustrate the calculation strategy. So let's get down to number 7. So 31 times 25, I'm going to think of 31 as 30 plus 1, and then of course I'm multiplying by 25. So if we switch that around, commutative property, we could read that out loud as 25 groups of 30 and 1. So 25 groups of 30 and 1 is 30 times 25 and 1 times 25, or 25 groups of 30 and 25, and 25 groups of 1. Now, if we use the associative property, we can associate the 30 times 25, or sorry, not the associative property, we're still distributing. So 30 times 25 gives us 750, plus 25 gives us 775. I also made a rough illustration over here so we could see that this is our section here, 30 times 25, and this is our 1 times 25 section. All right, looks like we're doing the same thing in number 8, but let me just double check our wording here. Explain how to calculate 29 times 20 mentally by using 30 times 20. So that's what we're going to lean on here, rather than you could think of it as, all right, I'm going to find 29 times 10 and then double that. But instead, we're going to lean on 30 times 20, and we're going to use a rough picture to illustrate this strategy as well. All right, so here we have 29 times 20. We're thinking of our 29 as our 30 minus 1. And so since we're thinking of that as 30 minus 1 times 20, what we end up having is 20 groups of 30, and we're subtracting 20 groups of 1. 20 groups of 30, of course, is 600, and that's just a really nice problem to do mentally, and so, of course, is 20 times 1. And so essentially what we're doing then is just subtracting 20 from 600, and we get 580. All right, and number 9. Where's number 9? There it is. Ted thinks that because 10 times 10 is 100 and 2 times 5 is 10, that he should be able to calculate 12 times 15 by adding 100 plus 10 to get 110. You have to explain to Ted 2 different ways that even though his method is not correct, his calculations can be part of a correct way to multiply the 12 times 15. Okay, so let's take 12 times 15 and think of it as 10 plus 2 times 10 plus 5. When we do that, we can make this array that shows we have a side of 10 and 5 and a side of 10 and 2. And so our partial products then are right here, 10 and 10, 10 times 10. Here we have 5 groups of 10. We also have 2 groups of 10 and 2 groups of 5. And so essentially you might be thinking, wow, this is just like FOIL. And it is, you guys, this is just like foiling out, but we're looking at how the distributive property plays out in that FOIL method. It's not a procedure we want to use until we can explain how it works. And so by finding the subproducts here, or all those partial products, we end up with 100 plus 50 plus 20 plus 10, all pretty efficient mental products. And then when we add all that together, we get 180. All right, and number 10, we have that working on this multiplication problem, 21 times 34, Sanjay says that he can take 1 from the 21 and put it with the 34 to get 20 times 35, and that this new multiplication problem, 20 times 35, should have the same answer as 21 times 34. Is he right? So I love this problem because this really reveals a lot of the misconceptions that students have. So let's take a look at this method. So this is what Sanjay's thinking. He's thinking that he can just take 1 from the 21 and add it over here to the 35. And he's forgetting that if we look back in number 9, he's forgetting that we have all 4 of these partial products to work with and not just 2. So let me see if I can explain that a little better. So first of all, his method is not correct. Maybe he can be convinced by showing him specifically what happens with equations when you represent 20 as 20 plus 1. So that's what we're going to do. We're going to think of 20 as 20 plus 1, and then we're going to distribute the 34 to the 20 and the 1. So take a look at how I did that. So this is our 21, and now we have 34 groups of 20 and 1. So we have 34 groups of 20 and 34 groups of 1. So we have 680 plus 34. If we did it his way, there, hopefully you can see that now. If we did it his way, we're looking at 20 groups of 35, right? Because he thought you could just take 1 here and add it to here. But look what happens when we do that. Let's think of 35 as 34 and 1, and then let's distribute out our 20. So we have 20 groups of 34 and 20 groups of 1. So we have 680 and 20. So those are not the same thing. Part of it is the same, right? So if you take a look at our 20 plus 34, or 20 times 34, that partial product in both strategies is still correct, but our one group of 34 and our one group of 20, of course, are not equivalent. If you're still confused about the Sanjay problem, I would suggest going through all partial products like this. Draw yourself an array for both the 21 times 34 and the 20 times 35, and you'll see which partial products are the same and which of the 4 are different. All right, number 11. This is our last one, I believe. Use the distributive property several times to show us why 10 plus 2 times 10 plus 4 is the same as 10 times 10 plus 10 times 4 plus 2 times 10 plus 2 times 4. So essentially, we're going to explain our FOIL method, and we're also going to draw an array to illustrate that. So let's get to it. So 10 plus 2 times 10 plus 4 is our 12 times 14. And I'm hoping that this illustration and how I use the arrows here will help you understand that. So when we have a 10 plus 2 plus a 10 plus 4, we have a section here that's 10 times 10. That's one of our partial products. We also have a section that is 10 times 2, another of our partial products. We have a section that is 10 times 4, our third partial product. And of course, we're going to have a fourth partial product, our 2 times 4. So we have 10 groups of 10, 10 groups of 4, 2 groups of 10, and 2 groups of 4. And if you're thinking back to FOIL from when you were in school, that's what we're doing here. 10 groups of 10, 10 groups of 4, 2 groups of 10, 2 groups of 4. And now we have a visual math diagram to help reinforce that. All right, that's it. I hope that helps everybody. Thanks for listening.